In our last video, we talked on total differential. Now, sometimes it is necessary to solve problems in which different quantities have different rate of change. So there is a need for us to evaluate dz dt. And given this is the formula for the total differential, we can also just divide all through by dt, and then we will have our formula for rate of change. So let's consider an example. We're given that if z is a function of x and y, and z is given by 2x raised to the power 3 multiplied by sine 2y, and we are required to find the rate of change of z, that's dz dt, when x is 2 units and y is pi over 6 radians, and x is increasing at 4 units per second, and y is decreasing at 0.5 units per second. So let's solve. Given this is the function, then our dz dt is partial derivative of z with respect to x, the x dt, plus partial derivative of z with respect to y of the y dt. Now let us evaluate our dz dx and likewise dz dy. Now dz dx is differentiating partial with respect to x such that y is kept constant. And if y is kept constant, we have sine 2y multiplied by the full differential of 2x squared, 2x cubed. And that will give us sine 2y multiplied by 6x squared. And that is 6x squared sine 2y. And if we are differentiating partially with respect to y, that means our x is kept constant. And we have a full differential with respect to y of sine 2y. And that's 2x squared. Differentiating sine 2y will have 2 cos 2y. And that will give us 4x squared cos 2y. Now, if we look at the formula, we have been able to evaluate dz dx and likewise dz dy. But let us look at the x dt, and let us also know what is the y dt. Now we look at the question. They say x is increasing at 4 units per second. That means x is positive 4. The x dt is positive 4. And y is decreasing at 0.5 units per second. Therefore, the y dt is negative 0.5 because it is decreasing. And we are given that x is 2 units and y is pi over 6 radian. So we will be required to evaluate the x, the z, the t. But then let us substitute necessary. So our dz dt as 6x squared sine 2y multiplied by dx dt plus 4x squared plus 2y multiplied by dy dt. Now when x is equal to 2 and y is equals to pi over 6, the dz dt, we can now substitute our value. It will become 6 into 2 raised to the power of 2 sine 2 into pi over 6 radians, where we multiply by dx dt, which is 4, plus 4 into 2 squared plus 2 into pi over 6 radian, and then we multiply by dy dt, which is minus 0.5. And then when we simplify this, we have that our dz dt is equals to 75.14, and its unit will be units per second. Let's take another example. Given that the height of a right circular cone, the height given that h is increasing at 3 millimeter per second, r is decreasing at 2 millimeters per second. I asked to evaluate dv dt in centimeter cube per second when the height is 3.2 centimeter and the radius is 1.5 centimeter. Now in this question we are dealing with the volume of a right circular cone, and the expression of volume of the right circular cone is 1 over 3 pi r square h. Therefore the rate of volume, that's dv dt, in this case it will be dv over the r multiplied by the r dt plus dv over the h multiplied by the h dt. Now since the height is increasing at 3 millimeter per second, therefore the h dt is equal to 3 millimeters per second, and converting this to centimeter per second, we have it to give us 0.3 centimeters per second, and therefore the h dt is equal to plus 0.3. Likewise we have for the r dt. We said the radius is decreasing at 2 millimeters per second, that is minus 2 millimeters per second. Converting it to centimeter, we have minus 0.2 centimeter per second. Therefore the r dt is minus 0.2. So with these parameters, you can pause the video and try to solve. So the first thing to evaluate is the partial derivative with respect to r and with respect to h. So dv dr is d dr of 1 over 3 pi r square h. And since they are differentiating partially with respect to r, our h is a constant. d dr of r squared, that gives us 1 over 3 into pi h of 2r. And that will give us 2 over 3 pi rh. And likewise, when we differentiate partially with respect to h, we have 1 over 3 pi r square h. Now, for this, our r is a constant, and we differentiate h with respect to h, and be left with 1 over 3 pi r square. Therefore, our dz or dv, dt our dv dt which is partial derivative of this with respect to r multiplied by the r dt plus partial derivative of v with respect to h multiplied by the h dt. So let us substitute our this, and then we have 2 over 3 pi rh, and our dr dt is minus 0.2 plus the v dh, that's 1 over 3 pi r squared multiplied by our dh dt, that's 0.3. And simplifying this, we have minus 0.4 divided by 3 of pi rh plus 0.1 pi r squared. And this is an expression for dv dt. Now we were given when h is equal to 3.2 and r is equal to 1.5. When h is equal to 3.2 centimeters and r is equal to 1.5 centimeters. Therefore, dv dt is minus 0.4 divided by 3 multiplied by pi of 1.5 multiplied by 3.2 plus 0.1 multiplied by pi multiplied by 1.5 squared. Now this will give us a final answer of minus 1.304 centimeter cube per second. Now this means that the rate of change of volume is decreasing by 1.304 centimeter cube per second. In our next video, we'll take another example on rate of change.